The oceans cover more than 70% of our planet. They shape our climate. They support life. They've been here for billions of years. But there's one simple question people rarely stop to ask. Why are the oceans salty? Where did all that salt come from? And why doesn't it just disappear? To understand why the oceans are salty, we have to start on land, specifically with rocks. Rainwater isn't just water. As it falls through the atmosphere, it absorbs small amounts of carbon dioxide. That creates a weak acid. When rain hits the ground, it slowly wears away rocks through a process called weathering. Over time, this breaks rocks down into tiny particles and dissolved minerals. Among those minerals are sodium and chloride, the two elements that make salt. As rainwater flows downhill, it carries these dissolved minerals with it. Streams feed into rivers. Rivers feed into lakes. And eventually, rivers carry those minerals into the ocean. This has been happening continuously for hundreds of millions of years. Drop by drop, river by river. Once those minerals reach the ocean, something important happens. The water evaporates. But the salt doesn't. When seawater evaporates, only the water molecules leave. The dissolved salts stay behind. Over time, this causes salt to slowly accumulate in the ocean. You might wonder why lakes and rivers aren't salty too. They receive minerals from rocks as well. The difference is that lakes and rivers have outlets. Water flows in, water flows out. Minerals don't have time to build up. The ocean, however, is the final destination. There's nowhere else for that salt to go. But here's where it gets interesting. If rivers have been delivering salt to the ocean for millions of years, why isn't the ocean getting saltier and saltier? Why hasn't it turned into a giant salt mine? The answer is balance. The ocean doesn't just gain salt, it also loses salt. Some salt settles onto the ocean floor as mineral deposits. Some is absorbed by ocean crust through hydrothermal vents. These vents act like underwater chimneys, cycling seawater through Earth's crust. As the water passes through hot rock, certain minerals are removed. Living organisms also play a role. Many marine creatures use dissolved salts to build shells, skeletons, and tissues. Over time, those materials sink and become part of the ocean floor. So while rivers constantly add salt to the ocean, geological and biological processes remove it. The result is a long-term balance. The ocean stays salty, but not infinitely salty. The saltiness of seawater even has a name. It's called salinity. On average, ocean water is about 3.5% salt. That means for every liter of seawater, there are roughly 35 grams of dissolved salts. Most of that is sodium chloride, the same salt you sprinkle on food. Interestingly, different parts of the ocean have different salinity levels. Areas with high evaporation, like the Red Sea, tend to be saltier. Regions with heavy rainfall or melting ice, like near the poles, are less salty. But overall, the ocean stays remarkably consistent. Saltiness also plays a major role in ocean circulation. Saltier water is denser than fresh water. Denser water sinks, less salty water floats. This difference helps drive massive ocean currents that move heat around the planet. In other words, salt helps regulate Earth's climate. So the salt in the ocean isn't just a flavor, it's part of a system that affects weather, temperature, and life itself. And when you zoom out far enough, something fascinating becomes clear. The ocean's saltiness is the result of time. Enormous amounts of time, billions of years of rain, billions of years of rivers, billions of years of evaporation, all quietly reshaping the planet. So in the end, the oceans are salty because Earth is constantly recycling itself. Rocks break down, water flows, salt remains, and over immense stretches of time, that simple process adds up. Once you understand that, the ocean feels a little less mysterious, not because it's simple, but because it's patient. This has been Questions Answered. If there's a question about the natural world you've always wondered about, leave it in the comments. And if you enjoy learning how everyday things work, consider subscribing to Questions Answered. Thanks for watching.